Hello friends, in this video we're going to solve 4th semester 2022 question paper of Elements of Modern Physics, that is quantum physics, and this is C-9, Dibrugarh University. BSc 4th sem. Right, BSc 4th sem. This is part 1, okay. Because I'm not gonna complete the paper in the same video, okay. And this is I am, and this is my Insta ID Oza Likhaji 123. This is my Insta ID. You can follow me if you want to follow me. Then before we start, please subscribe the channel. Also hit the thumbs up button so that you get notified when new video will be uploaded, and share with your friends and help me to grow my channel, inspire me to create new content for you. So now let's start. So here is the first question. We need to choose the correct answer here. The photocurrent depends on, this is question number 1a. So these are the options. So read the options one by one. Okay, first option is here frequency of incident radiation. Second option is intensity of the incident ray. Third option is both 1 and 2, and none of the above, last one. So which one gonna be the correct option here? So the correct option is the second option, intensity of incident radiation. Okay, so correct option is this answer. So question number 1a answer is option number 2, right? Now 1b, the size of the nucleus of an atom, of mass number a, if a is the mass number, is proportional to. So here a to the power 3 by 4, a to the power 2 by 3, a to the power 1 by 3, and fourth option is a. So which one is correct? The third one is correct, a to the power 1 by 3. So 1b answer is third option, a to the power 1 by 3. Right, now let's move on to the next question. The energy eigenvalue of a particle in one-dimensional box of infinite depth is proportional to. So here which option is correct? N square, n to the power half, none of the above. So which one is correct here? So tell me if you can. The correct option is option 1, n square. So 1c answer is n square, that is option number 1. This is 1c answer. Okay, what is the next question? The rate of spontaneous emission is proportional to. So what are the options here? The number of atoms in the higher energy state. Next option, number of atoms in the lower energy state, and third option is both 1 and 2. Then the last option is none of the above. So which one is correct? So correct option is number 1. So 1d answer is option 1. Okay, that is the number of atoms in a higher energy state. So last one, the gamma radiations are deflected by magnetic field only, deflected by electric field only, deflected by both electric and magnetic field, and none of the above. So which one gonna be the correct option? Option number 2, deflected by electric field only. Okay, so 1e answer is option number 2, right? So now let's move on to the next question. Question number 2, here answer the following questions. What is black body radiation? State the Planck's theory of black body radiation. So let's answer to this question. So let me take a blank slide. So answer to question number 2a. Black body radiation. So let me define it. The radiation within a uniform temperature, enclosure in equilibrium with the surrounding, with its surroundings is called blackbody radiation. Right, so this is the definition. Now we are to see the Planck's quantum theory. Okay, let me take another slide for this theory. So next is Planck's quantum theory. This Planck's quantum theory. In this theory, right, atoms in the walls of a black body are assumed as simple harmonic oscillator. Right. Oscillators having characteristics frequency of oscillator. Right. Suppose we have a black body. Hope you know what is black body. So here we have a small hole, and a black body can absorb the light of all wavelengths, right? So first it gonna absorb, and due to the absorption of light, temperature gonna be raised, and then it gonna start radiating energy, right? And here is considered that the atoms in the walls of this black body as simple harmonic oscillator, right? So according to this theory, the total energy released by these oscillators, it cannot have any arbitrary value. Okay, so that must be integral multiple of h nu, where h nu is called the basic unit of energy. So the total energy that gonna be released, that gonna be equal to integral multiple n can be 0, 1, 2, 3, any integer, okay, of this basic unit of energy. That means according to this theory, the energy is quantized. Okay, so that is the theory here. So let me write that one. I'll write the theory. According to this theory, a simple harmonic oscillator cannot have any arbitrary values of energy, but only those values of total energy that are given by E is equal to n into h nu, where n is equal to 0, 1, 2, 3, so on, called quantum number. It's called quantum number. Right. H is called Planck's constant. Planck's constant. And nu is the frequency of the oscillator. And H nu is the basic unit of energy. Right, basic unit of energy. So here we can say the total energy of oscillator. Total energy of oscillator is quantized. So we have understood this. Okay. So here you see the emission or absorption of energy occurs only when the oscillator jumps from one energy state to another energy state. That means now you see when this black body will radiate energy, this radiation is not continuous. Okay, so it gonna release this energy as the energy packet h nu, right, as energy packet. And and this released and this radiation occurs when those acid oscillators, that means those atoms which are considered to be oscillators, will jump from one energy state to another energy state. Suppose if it is one oscillator is one in a particular energy state, and if jumps to another energy state, then it gonna radiate energy. Okay, it gonna radiate energy, and which must be integral multiple of h nu, right? So this is all about the Planck's quantum theory of black body radiation. Now let's move on to the next question. In the next question we have, what is population inversion? Write the latest two methods of assuming population inversion. Okay, so let me write the answer. Let me take a new slide. So answer to question number 2b. So we need to write population inversion. So population inversion is the process by which population of electrons can be increased at higher energy state relative to lower energy state. Okay, relative to lower energy state. And two methods to achieve this are, let me write, is number one, optical pumping. And number 2 is electrical optical pumping and electrical pumping. These two are the methods. Okay, now let's move on to the next question. Next question is why it is impossible for an electron to be present inside the nucleus. You know, in atoms, electrons are revolving around the nucleus, right? Nucleus is positively charged. It doesn't contain in the it is not contained in the nucleus. It doesn't reside inside the nucleus. Okay, so now let me explain that. So let me go to a new slide to see answer. So here, to explain this, we must know the Heisenberg's uncertainty. According to Heisenberg's uncertainty principle, the uncertainty in position, that is suppose x, product of uncertainty in position, and that in momentum, that is greater than equal to h cut by 2. H cut is the reduced Planck's constant, or you can say h cut is nothing but h by 2 pi. So that's why h cut by 2, that's gonna be h by 4 pi, right? So here, what does del x represent here? So this is uncertainty in position. Uncertainty in position, and del p is uncertainty in momentum. Mass of an electron is given by 9.1 into 10 to the power minus 31 kg, right? And you see, del p is momentum, so mass into velocity, right? So, and one more thing, suppose this is the nucleus and its radius is r, then the electron to be reside within the nucleus, it must be within the range of twice r, right? So that's why its position to be in the nucleus, electron to be in the nucleus, right? Del x must be equal to 2 into radius of the nucleus, right? That is approximately equal to 10 to the power minus 14 meter. Okay, that means 2 times of radius means diameter, right? That's 10 to the power minus 14. So here you see, let me take this as 1 and this is 2. From 1 and 2, what we can write? From 1 and 2, what we can write is del x m into del v is equal to h by 4 pi, and del v, that's going to be equal to h by 4 pi into del x into me, right? So what is the value of h? So let's put the values here. A is going to be equal to 6.63 into 10 to the power minus 34 divided by 4 into value of pi 3.14. Then del x, as I have already told you here, it should be 10 to the power minus 14, and mass of electron 9.1 into 10 to the power minus 31, right? So if we calculate this, then we're going to get approximately equal to 5.79 into 10 to the power 9 meter per second, which is greater than the speed of light, right? So which is not possible, is not possible. So when we get this velocity, which is greater than that of light, when the electron resides within the nucleus. So therefore our conclusion is, electron cannot, electron cannot be present in a nucleus. So hope you have understood this. Now let's move on to the next question. Next question is here, you can see, state the Broglie hypothesis and write down the expression for the Broglie wavelength, right? So this is the answer to question number 2D, right? Write the answer. And if you add this part to your answer, then it's gonna be better. Okay, so it's gonna be better to score marks. Okay, so now let's move on to the next question. So the next question, 2E, is state the law of radioactive decay and what is half-life period of a radioactive substance. So let me take a new slide and let me explain that. 2E answer. So at any instant, the rate of radioactive disintegration is directly proportional to the number of nuclei number of nuclei of the radioactive element right? So this is the law of radioactive decay, right? So this dN by dt, the rate of radioactive disintegration, is directly proportional to the number of nuclei. Okay, so capital N represents number of nuclei. Okay, so now let me give you the definition of half-life period of a radioactive. So it is the time interval so let me write it properly. Time interval in which the mass of a radioactive substance or the number of its atom or the number of its atoms In exam, don't write the number this way, write complete word. Okay, is reduced to half of its initial value, half of its initial value is called half-life period. Sorry, so let me write half-life period of the radioactive substance. Okay, so remaining questions will be solved in the next video. Okay, thank you for watching. See you in the next video. Stay connected.